Hello, welcome. In this short video, let us look at some basic algebra of complex numbers. Specifically, we will look at how to represent any expression in terms of complex numbers as a single complex number. That is, the first one is a ratio of two complex numbers, that is 3 plus 4j divided by 1 minus 2j. This is equal to 3 plus 4j multiplied by conjugate of the denominator, that is 1 plus 2j divided by 1 minus 2j into 1 plus 2j. This one becomes 3 times 1 is 3, 4 times 2 is 8, so it is minus 8 plus j into 6 plus 4 divided by the absolute value square of this complex number 1 minus 2j, which is 1 plus 4 minus 5 plus 10j divided by 5. Therefore, the ratio is equal to minus 1 plus 2j. So, in order to write a fraction of two complex numbers or ratio of two complex numbers as a single complex number, we have to multiply both the numerator and denominator with the conjugate of the denominator. In this case, it is 1 plus 2j. Next one is a ratio of products of complex numbers, that is j times 2 plus j over 1 plus j multiplied by 2 minus j. In this case, first we have to simplify both the numerator and denominator respectively. The first one is obviously equal to minus 1 plus 2j. Second one is 2 plus 1 plus j into 2. 1 into 2 is 2 and 1 into 1 is minus 1 into minus 1 is minus 1, so we have 2 minus 1. So this is equal to minus 1 plus 2j over 3 plus j. And now multiplying with the conjugate of the denominator to the both numerator and denominators, we have 3 minus j over 3 minus j. So this becomes minus 1 into 3 is minus 3 and 2j into minus j is plus 2, and then we have minus 1 into minus j, which is plus j, and 6j. And the denominator is clearly equal to 3 square 9 plus 1 10. So this is equal to minus 1 plus 7j over 10. Therefore, the simplified version of this ratio of products of complex numbers is minus 1 by 10 plus 7j by 10. So the procedure is, first we have to simplify both the numerator and denominator as simple complex numbers or single complex numbers, and then we have to just multiply the conjugate to both the numerator and the denominator. The conjugate is of course for the denominator. Let us look at another example for this kind of expression, which is 2j multiplied by 1 plus j whole square. Therefore, we have three complex numbers here and then a single complex number in the denominator. So this equals 2j. First we have to simplify this expression, which is equal to 1 square is 1 and j square is minus 1, and then we have 2j divided by 3 minus j, and this one is obviously 0, so we have minus 4 multiplied by 3 plus j by 3 minus j into 3 plus j. So this becomes minus 12 minus 4j divided by 10, which is equal to minus, and 12 by 10 becomes 6 by 5 and 4 by 10 becomes 2 by 5 j. Now let us look at how do you convert a polar form, that is 4 into j pi by 6. So this is a polar form of the complex numbers or phasor form. So we can easily convert it by using the Euler's formulas, that is 4 times cos of pi by 6 plus j times sine of pi by 6. And this is equal to cos of pi by 6 is cos of 30, which is square root of 3 by 2, and sine 30 is clearly equal to 1 by 2. So this becomes 2 root 3 plus 2j. Next, let us look at a slightly more complicated polar version, that is square root of 2 multiplied by j 25 pi by 4. The magnitude or the amplitude is still square root of 2, and the phase can be rewritten as j, and 25 pi by 4 can also be written as 24 pi by 4 plus pi by 4, because 25 is 24 plus 1. So, but 24 pi by 4 is basically 6 pi, which is a multiple of 2 pi. Therefore, we have square root of 2 multiplied by j 2 pi whole cube multiplied by e power j pi by 4. And this, since e power j 2 pi is 1, this one is gone. So we have square root of 2 multiplied by e power j pi by 4. That is square root of 2 multiplied by cos of pi by 4 plus j sin pi by 4, which are both equal to 1 by root 2. Therefore, the complex form is 1 plus j. Next one is we have a product of a complex number j with the polar form, that is e power j 11 pi by 4. Here we have two complex numbers. First one is j and the second one is e power 8 pi by 4 multiplied by e power 3 pi by 4. That is, we write 11 pi by 4 as a sum of 8 pi by 4 plus 3 pi by 4. And since 8 pi by 4 is basically 2 pi and this is becoming e power j 2 pi, which is 1, so we can ignore it. So j times e power j 3 pi by 4. And this can be written as j times e power pi multiplied by e power minus j pi by 4. And this is equal to, and since e power j pi is minus 1, we have minus 1 multiplied by j multiplied by cos of pi by 4 minus j times sin of pi by 4. Therefore, the result is minus j multiplied by cos pi by 4 is 1 by square root of 2 and sin pi by 4 is also the same. So we have minus 1 by root 2. So we have minus of minus is plus, but j square is minus 1, so we have minus 1 by square root of 2 minus j into 1 by square root of 2. This is the final complex form. The next example is a sum of two complex numbers in polar form, that is 3 times j into 4 pi plus 2 times e power j 7 pi. This is equal to, for this kind of problem, first we have to simplify the expressions and then convert them into complex forms, and then we can easily add them. So 3 times e power j 4 pi is basically a multiple of 2 pi. Therefore, we have e power j 2 pi squared plus 2 times, and similarly e power j 7 pi can be written as e power j 6 pi multiplied by e power j pi. And this is clearly equal to e power j 2 pi cubed, which is equal to 1. So it can be ignored. And this is also equal to 1. So this is basically 3, and this is equal to 2 multiplied by, and e power j pi is minus 1, so we have minus 1. So the answer is 3 minus 2, which is 1. And finally, let us look at a polynomial of complex numbers, which is 1 minus j power 9. This can be rewritten as 1 minus j power 8 multiplied by 1 minus j. So first we can simplify 1 minus j power 8, which can be written as 1 minus j squared power 4 multiplied by 1 minus j. And 1 minus j whole square is clearly equal to 1 minus 2j power 4 into 1 minus j. And clearly this is equal to minus 2 power 4 is 16 and j power 4 is 1, and we have 1 minus j. So the final result is 16 minus 16j. So for this kind of structures, that is 1 minus j power 9, which is basically a polynomial, we can easily simplify that by using factorization. Thanks for watching.